Hello and welcome back to SQA Higher Maths Applying Differential Calculus. We're going to have a look at areas below the x-axis. So if we integrate y equals x squared minus 4x between 1 and 4, we will find the shaded area here. So let's do that. So integrate x squared, we get x cubed divided by 3. Remember, add 1 to the power, divide by the new power. If we integrate 4x, which is really 4x to the power 1, we will get 4x squared divided by 2, or just 2x squared. And then to evaluate that between 1 and 4, we substitute in 4, substitute in 1, evaluate what we have, and we end up with an area of -9. Now, what does an area of -9 mean? Well, you can't draw me a rectangle with an area of -9 or a square with an area of -9. But all the negative sign represents here is the fact that this area is below the x-axis rather than above the x-axis. Okay. So we would need to make a statement to show that we understand that when doing a question. So here, once I'd worked this out, I would be writing the area is therefore 9 square units. Or actually, I'd be writing all of this. In this case, the negative indicates that the area is below the x-axis, as can be seen from the diagram. The area is therefore 9 square units. So it just shows that we understand what's going on, and we need to do that. Just to let anybody who is looking at our work know that we understand. So in this question here, this is actually the two previous questions we've looked at. So the one above that we've just talked through, this area here, area 2, has an area of 9. Area 1, which we evaluated at the end of the first video, has an area of 2 1/3. So in total, 9 add 2 1/3. In total, the area is 11 1/3. Now, unfortunately, we can't just integrate between 1 and 5. Okay, because if we integrate between 1 and 5, as is done here on the right, we'll get an area of -6 2/3. Now, we know the answer must be 11 1/3. This has an area of 9. This has an area of 2 1/3. In total, the area is 11 1/3 units. Square units, sorry. So the sharper-minded of you will have spotted, well, -9 plus 2 1/3 gives -6 2/3. So what happens is the negative area and the positive area actually cancel each other out. So essentially it's giving -9 plus 2 1/3, which is where that -6 2/3 comes from, which again is obviously wrong if we're trying to evaluate the overall area. So what we need to do is to split this into two separate regions. Okay, so we'd find area 1, we'd find area 2, and then we'd add them together at the end. And this is just saying what I've just said above there. So let's have a look at an example where we do that. So calculate the shaded area shown in the diagram below. So again, we've got part above, part below the x-axis. So we'd find area A first. So we'd integrate 3 minus 2x minus x squared between -3 and 1. And then the same function between 1 and 2 to find the area below the x-axis. So integrate 3, we get 3x, integrate 2x, we get x squared, integrate x squared, we get 1/3 x cubed, or x cubed over 3. Substitute in our upper limit, substitute in our lower limit, evaluate, tidy it up, and we get 10 2/3 square units. We then need to do the same for area B. So remember, area B, guys, we're going from 1 to 2. So again, we're just integrating the same function. So again, it'll be 3x minus x squared minus x cubed over 3. And then we're going from 1 to 2. So again, substitute in the upper limit, substitute in the lower limit, evaluate what we have. We get -7/3 square units. So I've made my statement here. The negative sign indicates the area is below the x-axis. So then when I'm finding the total area, I basically ignore that negative sign. Now what we can't do is just write 10 2/3 plus 7/3. We must make this statement, okay? Unless you just want to throw away marks in any assessment you do, which I know you don't. Okay, so to find the total area, add the two areas we found together, and the total area is 13 square units.